This is an example where we have a variable dimensions. Okay, variable dimensions along the axial direction. Okay, this member is made from a material that has a specific gravity, specific weight gamma, and modulus of elasticity E. If it is it is in the form of a cone having the dimensions shown in the figure to determine how far its end is displaced due to the gravity when it's suspended in the vertical position. Simply speaking, this is a cone, and the bottom is fixed and the end downward. Okay, we're calculating the end displacement, the tip displacement, downward displacement under its self-weight. Okay, so in this example, the E is a constant. Okay, because the equation is shown here, we will use the third equation. Right, so here the fx is a variable, right, because it just depends on the self-weight. And the E is a constant, and A is a variable. Okay, A is a variable. But we will not use X since we're studying a Y system, a vertical system. Right, so we use Y. So we use Fy, E is a constant, Ay, dy. Okay. So this is our equation. Okay. So here we just need to determine the expressions of Fy and Ay, since the E has been a constant, right? So we're just determining Fy and Ay. Let's see how to find out these two distribution functions. Okay. So here, again, this thing is simplified into a cone, bottom fixed, and the tip pointing downward, and we're calculating the end displacement under its self-weight. Okay, and as I said, we just need to determine Fy. Right, since this overall this thing will be solved in such a way that the delta equals integral from 0 to L Fy over E Ay dy. Okay, this is the equation. So here we're finding out Fy and Ay. So to find out Fy, we should realize that we didn't add any external F. The only F is the self-weight. Right? It's the self-weight. So the Fy is just the self-weight. The self-weight equals the Vy, the volume, times the specific weight, the specific gravity. Okay, the gamma. Okay, so this is the expression. Then, since the Vy equals what? If we start from here, we set at the tip y equals 0. So the y is pointing upward. Okay, if we start from the tip to a random location, right, to a random location where the y coordinate is just y, right, and its cross section will look like this. The cross section will be something like this, and here we have y equals 0, and the y-axis is pointing upward at a random location here. Right. So we set that the height of this cone is y, and the x here is just a radius as the cut section. Okay, we said that x is the radius at cut section. Okay, knowing this x and y, so how can we calculate the Vy? The Vy would be 1/3 the area, bottom area of the cut little cone is times y. Right? Bottom times height over 3. This is the volume of this cone, right? And here we still don't know what is AY. So how can we determine AY? AY is just a circle, right? It equals pi x squared, right? Since we have set x is the radius as the cut section. But what is x? What is x? So how to determine x here? X can be determined from this figure, right? Since you can find two similar triangles, you can find two similar triangles. This is smaller triangle and the larger triangle. Right here, x over y equals what? X over y equals R0 over L. And R0 is the radius of the bottom. It equals R0 equals D0 over 2. Right? So from this equation, we can get that the x equals R0 y over L. Okay, so with this number, we can derive that AY equals pi R0y over L square or pi R0 square y square L square. Okay, so this is our AY. So from here, we can also calculate the VY. Right? So what is VY? VY is just pi R0 square y cube over L square, 3L square. Okay, so Fy can be expressed here. This Fy equals just V times gamma, right? So we will have pi R0 square y cube gamma over 3L square. So we get the expression of Fy, that is the force. Okay, Fy has been found out, so we just need to find out Ay. Ay actually has been solved, is here. So we already have Fy and Ay, right? So we can just go back to this initial equation. Substitute this Fy and Ay into the original equation. So we will get delta equals 0 to L Fy over E Ay dy. Right, that is pi R0 square y cube gamma over 3L square over E times pi R0 square y square over L square. So you can see that a lot of things will be gone, the L square be gone, and pi R0 squared gone, y squared gone, left 1y. So you have just a gamma over 3e. dy. So we have 0 to L gamma y over 3e, right, dy. This one will be gamma over 2 times 3e y squared, right, from 0 to L. So easily we can get the expression, the final expression of this delta. That will be gamma L squared over 6e.